to attempt to go ahead and do this online training. I know this is going to be very different for a lot of people, but maybe not so much for the people in my class that are used to following along with the video. Today we're going to go over lesson 6-1, populations and samples. First of all, they say that the table shows the lunch items sold on one day at the middle school cafeteria. Use the given information to help the cafeteria manager complete his survey or his food supply order for next week. So what he's trying to find out is what people are eating so he knows how much to go ahead and buy. Because the thing that he wants to do is order the thing that most of the people are eating, so that he'll keep on having the stock in there to supply the demand of the customer. So the first thing we have to do is add up all of the total here of the numbers sold. So we're going to have to add 43, 51, 14, and 127. And then to know the total amount that a percent that turkey sandwiches would sell, then we would divide 43 by that amount. Well, we can see here that when we add 43, 51, 14, and 27, there's 135 total things sold. The turkey sandwich is only 43 of those. So remember, every fraction is really a division problem, and that's what gives you a percent. So 43 divided by 135 will give us 0.32. And when we turn it into a decimal, we move that decimal point over 2 spots, and it will give us 32%. So that means a turkey sandwich is 43 over 135, or about 32% of lunch items sold. For this specific example, I'm going to go ahead and get the calculator and make sure that the book is right, because we know that we've run into situations this year where the book is not always right. Okay, and on our calculator, we see that if we add 43 plus 51 plus 14 plus 27, we do indeed get 135. Now we realize if we take 43 and divide it by 135, that gives us 0.31851. Now, a lot of you are thinking, well, that's not 32, Mr. Mendes, but remember, we round up to the hundredths, and 8 is bigger than 5, so we will increase the 1 and make it 2. So that makes 0.32. We move that decimal over 2 spots. That's where we get the 32% of lunch items sold. That was the only example I'm going to show dividing that, because we've been doing that all year long. We're going to go back to this slideshow now. If we took the hot dogs, we'd see that we have 51 hot dogs out of 135 things sold. And that means if we take 51 divided by 35, we're going to get roughly 38% of the lunch items sold being hot dogs. If we take 14 of the veggie burgers out of the 135 things sold, we'd have 14 divided by 135, which would give us roughly 10% of the lunch items sold. And the fish tacos make up 27 of the items sold. So we'll have 27 divided by 135, which will give us 20% of the lunch items sold. For next week, 32% of the lunch orders should be turkey sandwiches. 38% should be hot dogs. 10% should be the veggie burgers. And 20% should be the fish tacos. Moving on, it says, focus on mass practices. Construct arguments. Why must it be helpful? Why might it be helpful for a cafeteria manager to look at the item ordered on more than one day? Well, let's think about that. On one day, a lot of people might be going ahead and ordering something. Let's say it was Friday, and the Catholics were out saying they can't eat meat, so they bought a bunch of the fish tacos. Well, that doesn't mean that every day fish tacos are the most popular thing, right? So you have to go ahead and if the manager looks at more than one day, he can see students tend to order the same items on each day or if their preferences vary. So just like with the example, we want to make sure that we're looking at a broad spectrum of days and seeing exactly what percentage of things are being sold more than others and average that in. In this particular example, it says the 2,468 registered voters in Morgantown are voting on whether to build a new stadium. Morgan and her friends really want to show that to vote in favor for the new stadium. How can they determine how the voters will vote before the day of the vote? Well, what you could do, they could go ahead and check out the population. Morgan and her friends could ask every registered voter in the entire population of voters in the town how they plan to vote. And I mean, if you think about it, if you ask everybody how they plan to vote, that's going to give you a pretty accurate idea of if they want the stadium or not. However, surveying 2,468 people takes a long time. Morgan and her friends may not be able to survey the entire population of voters. Morgan and her friends could ask a subset, or what we call a sample, of the registered voters in the town how they plan to vote. Surveying a sample of voters does not take as long, and it is more reasonable to do it. Morgan and her friends would be able to ask maybe 100 to 200 people out of that 2,468. And depending on the percentage of those people that decided to vote for the stadium, they'd get a good idea whether the stadium was wanted in the area or not. Now, is this going to give us a 100% guarantee on what the majority of people want? No, of course not. Even when we see elections go by, the best we can do is go by the statistics. But in the end, if the statistics just happen to be a bit off, well, we could find the person that we thought that was going to lose as our next president. Here we go with our try it. Miguel thinks that the science teacher in his schools give more homework than the math teachers. He is researching the number of hours middle school students in his schools spend doing math and science homework each night. Well, it says blank, the blank includes all of the students in Miguel's middle school. Remember, earlier we said the population is what includes all of the people. So since we're talking about middle school students, we're talking about the population of the students at Miguel's middle school. Next, it says a possible blank is the sum of the students from each of the grades in the middle school. Well, the minute we said sum, we know we're talking about a sample of the kids that go to the school. Now notice it says from each grade. We would not want to go ahead and just survey the 5th graders or the 6th graders or the 7th graders. You want to get a good sample from each grade because different kids in each, the kids in each grade might have different priorities and be at a different maturity level. Thus, their vote might be different on whether they think math or science is giving them more homework. Next, it says convince me. Why is it more effective to study a sample rather than an entire population? Let's not forget that first example. An entire population can be a pretty big number of people. So many populations are so large, it would take too long to survey everyone. It's also very expensive. Think about who you're going to have to go ahead and pay to go and ask all those people that question. In our example here, it says Morgan decides to survey a sample of the town's voting population. How can she know that the survey results from the sample of voters how can she know that the survey results from the sample of voters represents the position of the entire town's population? Well, a representative sample accurately reflects the characteristics of the entire population. We do this because they represent the topic that we're talking about. Let's just say in this case, we're talking about the voting population. That would include everybody. So that would be a representative example you could take from any place. But if you're going to say, let's just say, who is your favorite, or do people enjoy sports or not? It wouldn't be accurate to go to a football stadium and ask everybody that exited the stadium if they enjoy watching sports. Those people bought tickets to that event, and that means more than likely they're going to have a bias. They're going to want to go ahead and say yes. So you have to make sure that the sample you take is a representative sample that reflects the characteristics of the entire population, not just some. In a random sample, each member of the population has an equal chance of being included. A random sample tends to be a representative sample. In a random sample, you might just go ahead and say, all right, everybody gets a number and I'm randomly going to select it. Or put them on a list and then randomly select people from the list through some type of automated system where it does not include any type of bias. Morgan can survey a random sample or randomly selected group of voters to make sure her result represents the position of the entire town. Let's try it. It says here, a produce manager is deciding whether there is customer demand for expanding their organic food section in her store. How could you obtain the information she needs? Well, remember, since we're talking about the people in her store, she could survey randomly selected shoppers to form a representative sample. They represent the people that go to the store. Who you wouldn't want to go ahead and ask in this particular sample or to be a part of the sample would be people that went to another store, or maybe people that did not like organic food at all. How can Morgan generate a random sample of the town's voting population? Morgan can follow these steps. First of all, define the population. The population consists of the registered voters in the town. Next, she could choose the sample size. Morgan plans to survey 100 registered voters. But remember, the larger the sample, the more confident Morgan can be that the result represents the position of the population. Next, we can make or acquire a list of all the members of the population. Now, if we do this, we're sure to get more of a random sample than just going ahead and picking maybe 100 people from the same neighborhood. Step 4, assign a number to each member of the population. When we do this, it gives everyone an equal chance to be selected into the sample. Just think about how big the area is around Pensacola. Some of the areas are very well off and the people have great resources in their home, but some of the areas are socially, economically challenged and don't have a lot of the resources that others do. This could go ahead and change the way people vote about the people that they're representing, depending on maybe the education they want in their town, or maybe the raising the minimum wage for a job. Generate a list of random numbers to select sample members. All right, in this case, once we've got all numbers, a number assigned each person, we're generating that list by just selecting numbers at random, and it doesn't matter whose name is next to that number. We're going to ask that particular person what they think their vote would be. Let's try this one. It says here, Ravi is running against 2 other candidates for student council president. All of the 750 students in Ravi's school will vote for student council president. How can Ravi generate a representative sample that will help him determine whether he will win the election? Well, Ravi can assign each student in the school a number and randomly select numbers until he reaches the desired sample. Let's say he wanted to do 100 students. He would assign each 750 students one number, 1 through 750, and then randomly select numbers, and then he can go ahead and ask those students who he thinks that they would vote for, or who they think they would vote for, and that would give him an idea of how he's doing in this election. Morgan and Mandy will generate a random sample of 138 students in 7th grade at their school. They each write the number from 1 to 138 on a small piece of paper and put them in different hats. Then they draw 20 numbers randomly from their hat. What do you notice about the two random samples taken from the same population? What does this tell you about the sampling technique? Well, Morgan's sample and Mandy's sample, you might notice, only had two numbers that are in common, 38 and 106. There are 20 members in each of their samples. Only the numbers common to both samples were 38 and 106. The numbers are distributed differently in each sample. You have one sample here and another here. The sampling method produces random samples that have mostly different numbers, but that are each likely to be representative of the population. Let's try it. It says the table at the right shows the random sample that Jeremy generated from the same population as Morgan and Mandy's sample. Compare Jeremy's sample to Morgan and Mandy's. In this case, Jeremy's sample also has 20 numbers. The number 36 is also a number in Morgan's sample. And we're going to go back just to check that. And Morgan's sample does have 36 in it. Uh, 126 is also in Mandy's sample. So they're saying that 126 right here is also in Mandy's sample. And there it is. There are no numbers common to all three student samples. So when they're saying the table at the right shows this, and they want you to compare it, they're simply stating that you can take 20 different samples from the same population 3 different times, and you might not get one sample or one person in any of those 3 samples that's the same. All right, these are the key concepts that you're going to take on to working in your practice and problem solving when you do your homework. A population is an entire group of objects, people or animals, plants, from which data can be collected. A sample is a subset of the population. When you ask a statistical question about a population, it is often more efficient to gather data from a sample of a population. So basically they're saying, if you've got a big population, you may want to take a sample of it so you'll be able to go ahead and get an idea of what the population data is going to reflect. A representative sample of a population has the same characteristics as the population. Generating a random sample is one reliable way to produce a representative sample of a population. A representative sample might be if we're talking about an election and we want to include all the registered voters. They are the representative sample of the people that are going to vote. Now, if you're not a registered voter, you would not really be in the representative sample. Now, if you took a random sample of that population, you're going to want to select people only that are registered voters. So maybe there's a population of 4,000 people, 3,000 of them are registered voters, and you take a sample of them, let's just say 300 of those people, to try to find out which way people are voting in the election. You can generate multiple random samples that are different, but that are each representative of a population. In this particular case, they're showing a population and then the random sample that was selected from it. These people are all voting different ways. As you can see, by taking the random sample, it looks like there was more people thinking red than green. And in this poor sample, none of them were selected for their blue opinion. How can you determine a representative sample of a population? Well, remember, you can generate a sample that will likely reflect the same characteristics as the entire population. When you do this, you get a good idea of what the population thinks, okay? A representative sample all has things in common with that population that you're talking about. Why does a sample need to be representative of a population? Well, so it best reflects the characteristics and positions or opinions of the population from which it's drawn. If I were to go ahead and ask the people, and let's see, it says representative, why does a sample need to be representative of the population? If I'm going ahead and talking about sports, but then I'm going to a group of artists that never go ahead and do anything with sports, they're really not going to accurately reflect the characteristics of the population of sports people that I'm asking or that I'm trying to inquire information about. Be precise. The quality control manager of peanut butter manufacturing plant wants to ensure the quality of the peanut butter in the jars coming down the assembly line. Describe a representative sample method that she could use. Well, I would go ahead and think you would want to number these. Yep, use a random number generator and a spreadsheet that will order the numbers. Then take the jars off the assembly line whose position in the line matches the generated numbers. We have no idea which jar of peanut butter is going to be picked. They got picked at random. So we'll have a good idea if a batch is bad or not. The health club manager wants to determine whether the members would prefer a new sauna or a new steam room. The club surveys 50 of its 600 members. What is the population of the study? Remember, the population is the total. So that's going to be the 600 members that are in the club. Next, a journalism teacher wants to determine whether his students would prefer to attend a national writing convention or tour of a local newspaper press. The journalism teacher has a total of 120 students in 4 different classes. What would be a representative sample in this situation? Well, the teacher could put names of the 120 students in a hat and randomly select names to create a random sample. Why wouldn't you want to just pick from one class? Well, what if you have a clique in that class that kind of persuades all the rest of them to vote one way? You want to go ahead and get a good sample from all the classes in order to find out what all 4 classes are thinking. Next, Garrett wants to find out which restaurant people think serve the best beef briskets in town. What is the population from which Garrett should find the sample? Well, that's the residents in the town because they're the population. All the people that go to eat at the restaurants are the people from the population of the town. What might be a sample that is not representative of the population? Well, what if you went into one of those restaurants and just picked one of the customers there? Well, that customer at one of the restaurants that serves beef briskets is not going to be a good representative of the population. They've already kind of decided which one they want to go ahead and go to already. You definitely want to pick people outside of the restaurant because you have no idea if they go there or not. Next is your practice and problem solving, and this is for you to do. Please go to the PowerPoint and go to each page and fill it out as best you can. Good luck, and tomorrow I'll put the video with the answers to all of these practice and problem solving so your parents can grade them. Have a great night.